Yeah, save all your finals until we take the final. And you pass all that stuff in at the same time. Well, so for today, I think we're gonna do today. We stopped with we were working on ignition systems. We stopped at the glow plug. So we're gonna pick it up from there. It's just a little bit left.
You said that the glow plugs were more for even colder weather?
For what?
Cold weather?
They work for cold weather, but they work for warm weather too. Yeah, the whole point behind those things is that they preheat the air, and then when you swap fuel past it, the fuel is going to be heated by that glow plug. It's going to be heated at that nozzle. So those nozzles are kind of like they're really like not a nozzle. They're more like just a tube. When the tube gets hot, and the fuel runs through that, then it causes it to vaporize. So that's the instead of having a nozzle that does it, you just vaporizing the fuel with a hot piece of metal. Sit down here, so a little different. It works better in colder weather. It works in all different climatic conditions, but it works better in colder weather.
And then do they run the igniters just because it's cheaper?
Do they what?
Do they run igniters because it's less expensive or less maintenance or?
No, it's a simpler system. Actually, the glow plug is a simpler system, but the glow plugs, when they get loaded up with carbon, because that's what they do. They get loaded up with the carbon part of the fuel. It turns it into it starts shortening the filaments or the windings, and then you don't end up with as good a heat. You don't end up with as much heat. Okay, so we got bats, ooze, there, Serrera, Farmer, Floss, Ford, Bill Brand, Jones here, Jude, we saw him, Kennedy's here, Kefis, Clark, Williams here, Kinder, God, that's here, Skalko, here, Manning, Morgan's here, Myrick's here, that's back there.
No.
Oh, okay. Win. And Zone. It's a son of a bitch to get old, isn't it?
Yeah.
Rodriguez.
I wouldn't recommend it, but it's a little late, isn't it?
Yeah, it's a little late. Where you figure it out. Silvis.
It's never too late.
Devora.
Right?
Yeah, then the stuff sneaks up on you, you do something real innocent, just pick something up. But it's the end of it. And then the rest of your life, you gotta deal with that shit. And it really doesn't matter how flexible you are or what you do. Just live with it.
Yep.
Mark's kind of got that same thing going on. He's got this little daughter, she's got the wiggle work. And he picks her up, of course she's getting big, she's starting to get heavy, and he picks her up, swings her around like she's 2 years old. Yeah, she'd tear him up for a week at a time. Okie dokie. So we're gonna balance the prop on that PT6. I don't know if we'll get to it tonight or not, but we'll do it at least in props tomorrow. Mark's probably gonna need a little bit of help fitting some stuff onto it. Looks like our test cell is about done.
Next semester.
Yeah, I'm thinking we might get one run out of it in the next week or two,
That'd be cool.
just to see how it works.
Yeah.
They have this thing, some kind of a nebulous thing they call a punch list, and the punch list is all the little loose ends that didn't get done. And then we have a fire detection and smoke detection system in there that we can't control.
You don't need that.
We kind of need to, because I don't want to have the big red truck showing up every time we run an engine out there.
So we gotta hang a vest sock over every time?
So,
Every time?
Yeah, spray some jiffy foam over the sensors or something. I don't know, but, they're telling me I have to call the dispatch people every time we run the engine, and I said that ain't gonna work. So that's one of the problems we still got dangling with the test cell, but otherwise it looks like it's pretty well done. I'm anxious to get out there and kind of raise hell with it a little bit. All right, so the last time we met, I had you think about this a little bit. It's good, I guess. So this is kind of like a cigar lighter inside your car. Push the thing in, it gets hot, pops out, and this whole coil here gets hot. These things get almost white hot, and so they get a little bit hotter than the ones in your car. But you can see the carbon up here, and this is just the solids in the fuel that eventually build up on there. It's kind of like, I use the analogy of my oven at home. You cook a couple of chicken pot pies in my oven, and pretty soon it looks like that. And so we have to get that stuff out of there, or you leave it in there, one or the other. And I choose not to because it just gets worse. But what happens is the more you bake this carbon, the harder it gets, the more glass-like it gets. So the only way you get it out of there is with a caustic compound. And easy off oven cleaner seems to work pretty good for that. You can soak the end of it in here and use a very light brush to break it and just get it out of there. You might also use something with a little sharp fine point on it to break that stuff out of there. But once this starts shorting out and killing the heat that happens across these coils, now you start losing the starting efficiency. Because what you're trying to do is heat up the air that it goes into the engine. You're also trying to cause the fuel to vaporize when it hits that hot middle. So those two things, this thing needs to work pretty efficient. The price of these things, as opposed to an igniter, about $650 for this little jet. $650. It's only like that long. We got two of them in our PT6 outside out here. And we started all of a sudden having a problem getting the engine started. Pulled these things out and found they were full of this carbon. Okay. All right, so let's talk about some maintenance on these systems. And this is something you'll be involved in. Most of these things, there's nothing really that you can do to this stuff. Take it out and replace it. But there is some things when you start having starting problems. There's some things that you need to do to ensure that you get a quality start every time. Okay. Now, before you do anything, make sure the system is discharged. That means taking a trip to the flight deck or the flight station and pulling the circuit breaker on the ignition system and putting some sort of lockout on that circuit breaker. You all know what I'm talking about when I talk about a lockout? Okay, it's going to be something, circuit breaker's got a knob, pull the knob out. It's a little, usually it's an orange device, it's got a little flag on it that attaches, got a ring around it, somehow snaps on there, that tells anybody else that goes up in that flight station or on that flight deck that that system is disabled. And you don't be resetting that stuff. If you didn't set it, don't reset it. Okay? It's the responsibility of the person who pulled that breaker to go back up and reset it. Now, most of these systems are going to bleed down. That is to say, the exciter box will bleed down in a matter of minutes. Figure 10, good safe number. If you get across one of these things, you can have that 20 or 30,000 volts run right through you, in which case it's going to be a pretty bad deal for you. Minimum, so big burns, maximum it could kill you. So be careful around this stuff. They're not inherently dangerous, but they can be dangerous if you don't treat them with some respect. Now, most of these things incorporate some sort of bleed down resistor. So the capacitor inside the box, inside the igniter box, is going to hold the charge for a certain length of time, especially if the engine has just been run. And if that's the case, that resistor, a pretty high resistance to ground, but it's going to allow that capacitor to bleed off. And that's going to be inside that 10-minute period. That's always, there's engine maintenance manuals. There's something else called CMMs, component maintenance manuals. Any of you ever hear of those? So they go one step deeper than the engine maintenance manual or the aircraft maintenance manual. So the AMM or the EMM, those are going to cover kind of broad spectrums of things on the engine. So let's say you have to go into the ignition system, you're going to use what they call a component maintenance manual, CMM, right? CMM, and that's going to get you down into saying things the size of the igniter plugs, the harnesses, and the exciter boxes. It's going to take you down in one step lower into a little bit more detail on the stuff. It's going to tell you what you can work on, what you can't work on. All right. So you always have maintenance manuals. Most all the manuals, there's a paper copy always around somewhere. But the other thing too is most everything is on hard drives or it's on CDs. So a lot of shops will have the whole stack. They'll have a CD player that will take 6 or 8 CDs. What you do, you just feed the things in there for the appropriate aircraft or engines. You can full jump between pages, usually 2 or 3 monitors, so you can practice stuff. So what you're looking for when you have igniters, so our PT6 doesn't have the snapping sound, but when you have igniters, you're going to have that snapping sound in the tailpipe. And that's going to ensure, if you hear that, you know that you have a spark occurring in the back of the engine. Now, you can hear it from the front of the engine, but you're trying to listen through all the compressor blades and most of the engine. If you listen to it from the back end or the tailpipe end of the engine, you don't have all that stuff in the way. It's usually just a couple stages of turbines, a big cam that echoes in there, and it's going to be instantly recognizable as a snapping sound in the ignition system. Now, most of these systems, I know our little engines out here are only single channel. Most of them have dual channel systems. That may be one exciter box with 2 channels, or it might be 2 exciter boxes with 1 channel apiece. That kind of depends on the airframer, how they wanted to set it up for any given engine and airframe installation. So if you have a dual channel system, you've got 2 exciter boxes or 1 box with 2 channels, and you're going to have 2 spark plugs. Now, when you go to troubleshoot these things, if you don't hear that snapping sound and the ignition's been applied, you start upstream. Start upstream. First of all, is the breaker closed? Next thing, is the switch providing power to the exciter box? no snapping sound. You just start working your way downstream. Follow the power. Okay, so you don't have any power to the exciter box. Then you've got an airframe electrical issue. And you can track that down pretty easily. But be sure the circuit breakers are set. You might want to pull the breaker out and then reset it again. Breakers go bad. Pilots have a habit of fooling around with circuit breakers in flight. They like to pop them and stick them back in, and pop them and stick them back in all the time. What does that do to the circuit breaker itself inside? How many of you have ever seen a circuit breaker taken apart? 2, 3, 4, 4, 5 of you? Okay, so you guys explain to me what happens if you constantly set and reset a circuit breaker.
It wears out. A little catch, because all it is basically a little, lack of a better descriptive word, a little latch and sear.
Mm-hmm.
And the way that it works is like it gets hot, and then just enough, and then it pops out at a certain amperage or temperature.
Certain amperage,
Also,
exactly right.
Points, there's a set of contacts
Contact
inside of the
points,
circuit
yeah.
breaker. And
Yep.
if those open up enough times that they can arc and, metal transfer.
Yeah, it's going to kill the breaker is what it's going to do. And every time you open the breaker and close the breaker, if there's anything downstream that's consuming any electricity, you're going to have an arc jump across, right? So the way it's supposed to work is they got the contact points in there, so when the temperature gets too high, the lone little finger straightens out and the whole thing just unlatches itself. Okay? There's a spring that causes the button to pop out. Now they'll stay set even though they don't work worth a darn. It should have a pretty good click to a circuit breaker. If you have one that's kind of mushy, push it in, it kind of goes, it's like stepping in oatmeal. Then you've probably got a bad breaker too. So that's not going to allow any power to run through the breaker. And that comes right off the aircraft bus. It comes off the aircraft bus, so it's going to have power going to one side of the breaker, but it may not be coming out the other side of the breaker. Same with the switches. So we use the circuit breaker for what purpose?
Overload, to
Overload?
protect the circuit, right?
Yeah, we're protecting the circuit with the circuit breaker, right? It's not to really be meant to be used as a switch. So we use it for safety purposes. We'll pull the breaker and we'll disable the system. But that's all it's really for. And so once it's reset, the whole system is active again. So after or following downstream, one step after another, you're going to have some kind of a switch, whether it's a push switch or it's a toggle switch. You're going to have some switches that are going to activate the ignition system. And that switch also should have a good snap to it. Right? These switches are meant to control the power out of the circuit breaker, but they're not meant to be something that offers circuit protection. And so the switches will occasionally get soft and mushy too. They won't reset real tight or snap. They all click. All your experiences with clicking switches. But if you get a switch that kind of goes mushy when you reset it, you probably have a problem with the switch. So you may have power into the switch, but nothing may be coming out of the switch. Or it may be a high resistance in the switch, causing not much power to go through the switch. So there's all these little things that can occur insofar as troubleshooting goes. So when you put your voltmeter on the Cannon plug or on the receptacle that comes to the exciter box and you find no voltage there, you find low voltage, what are you going to be thinking?
High resistance.
High resistance, okay? Which means you're not getting enough voltage to have the exciter box do its trick. I know all this sounds kind of like a pain in the butt, it really is. You don't ordinarily have problems with these systems, but I want to take you from one step to the next on how to figure these things out. And if you're smart, you'd be drawing a little line, a little arrow, next thing, you'd be making some notes for yourself. Because one day you're going to be having to troubleshoot one of these things. You're not going to have power to the box. You're going to be be thinking, oh, airframe electrical, I never liked that class. It just isn't that hard. All right, so you got no power to the box isn't gonna work, the ignition system's not gonna work. Let's say that you do have power at the plug to the box. You know you've got power, you checked it with a voltmeter, you plug it back into the exciter box and you still don't hear any snapping sound. What next?
Check the outputs on the exciter box.
Check the outputs on the exciter box. Now this is something you have to be a little bit careful with because you're gonna be playing with fire here. So you disconnect the igniter, take it right out of the engine, hook it back up to the lead and let it hang. Now remember, the igniter has to be grounded to the engine somehow, or so you're laying against the engine or something. What you're looking for is you're looking for that spark to occur. If it doesn't occur, you've got something else going on. So it could be at that point two things. What could it be? Well, actually three.
Shorted
Box.
So it could be the box.
Lead.
What else? The lead.
lead.
And what else?
Igniter.
The igniter. So the percentage of probability is way, all the way to the moon that it's gonna be the igniter. Okay, so the igniter lives in a world of hell. It's always heat, it's always got electricity going through it, it's always trying to be burned up, it's always trying to be consumed. And so when you start thinking about it, the igniter is a thing that is probably gonna be the problem. Boxes and leads, not so much typically. So if you've looked at the lead, you take and hold this thing in your hand, you can follow your hands down there, there's no breaks in it, it hasn't been compromised in any way. You look at the box, smell it. Does it smell like the smoke's escaped out of it? Right? No, doesn't smell like the smoke's escaped. There's no burn marks on the box. It's probably the igniter. You take the igniter, take another igniter, screw it in, and hallelujah, maybe the thing will work. So if you have a dual channel exciter box, one lead works, or one spark plug works, the other one doesn't, you can take the spark plugs and swap them and see if the problem follows the swap on the plugs. Does that make sense? So if you swap those plugs, and now the other side is firing, the other side's not, you know you've got a bad lead, you've got a bad spark plug there somehow. Okay. Does that make sense? Okay, so after the power to the box, if you still haven't got a spark, it's probably gonna be an igniter. Those things get changed all the time, yeah.
Did the igniters disconnect from the lead?
The
From the lead
igniters-
coming from the box? I mean, like a spark plug, can you?
Yeah, it just
disconnect?
unscrews. Yeah,
Okay, so if you had another one, instead of taking the one out of the engine, you could just,
you can just stick it on there.
yeah,
Yeah, exactly right. Yeah,
and then at least prove or disprove the box.
exactly right. And usually what happens is, you're gonna find somebody or the shop is gonna keep an igniter that maybe is worn out a lot, but it's not bad, and it's a known good igniter. You just screw it in, and that way you're not spending money on an igniter when you don't need to spend the money.
Or pulling stuff out that doesn't need to be pulled
Sure,
out.
yeah. So shotgunning, there's a method of checking things called shotgunning, and that means you just start changing parts, right? Well, nobody but the military can afford to do that, because this stuff's so darn expensive. And it really doesn't tell you what worked and what didn't work. And you know, if you got a jet or something, you gotta get in the air in the next 3 minutes, and you're gonna be changing all those pieces to make it happen. But what's gonna happen is, one thing is you're gonna learn something by troubleshooting these things. You're also gonna save money by running these things to ground one issue at a time. And it doesn't take that long with this stuff. It all this stuff screws together, it's got nuts on it, and it goes together pretty easily. All right, so the igniters. Again, the percentage of probability that you've got an igniter issue is almost 100%.
So you want to check those first?
What's that?
So you want to check those first?
Well, you don't know if you've got power to the exciter, so you have
Check
to
the breaker.
make sure you got power to the exciter first. Yeah, so that'd be the first thing you do. The next thing then would be the igniter itself. Of course, if you have one, if you have a dual channel, one's working, one's not, swap them. And that's gonna tell the tale right there. Now, there's something else I should tell you about, it's called sunshine and fresh air. For no good reason, a lot of times you'll touch something, you'll take it apart, it looks fine, and you put it back together, and it works perfect. A little sunshine and fresh air sometimes can fix a lot of things, but it's kind of maddening because these transient problems are almost certain to show up again at some point. So you haven't really fixed anything, but you made it work. So be careful doing that. Don't try not to fall into that trap. All right, so the igniter plugs, we're going to use these to ignite the fuel, start the engine. The failure of those things might be for any one of those reasons there. Usually it is worn or eroded electrodes. If you look at the leads that go out to the igniters, you can pretty much tell if there's some damage to them. They're pretty simple, simple wire. If they've got a kink in it, you find grease on it where somebody uses the foothold, then you can start suspecting the leads. But the leads last quite a long time. They'll go through a complete engine overhaul. Now, internal flashover on one of these igniter plugs certainly can happen, but it's usually induced by a mechanic. When you put the, when you assemble these things, what happens is you use a certain amount of anti-seize because we're dealing with very high temperatures here. You put anti-seize on the threads of the igniter where it screws into the engine. And that stuff, I've said this before, some of you heard me say it, you can have it on your hands. When you go home at night, having not taken your shoes off yet, and you're going to have it on the bottom of your shoes. This stuff gets everywhere. It just finds its way into everything. So be sure that you work super clean with this stuff. It's better to use gloves as you go through different phases of the setup and the installation. Peel the gloves off and throw them away and throw them in a trash can because you don't want this anti-seize. Anti-seize is made up of nickel, cobalt, it's made of copper, and it has an oil base to it. This stuff prevents two similar metals from seizing against one another. So the spark plug shells are made of steel or high nickel steel, and you screw them into stainless steel housings. You don't want them to seize. You want to be able to get them apart later on. So you're going to use anti-seize to prevent this from happening. But there are only certain places that you want the anti-seize deposited. And you can slop this anti-seize on. It's not like a spark plug for a reciprocating engine. You got to be super careful where you put it. You can slop this stuff on the threads real easy. Screw everything together, take a little rag, wipe it up, throw everything away, get everything cleaned up. But you don't want it on the flash well or the lead well on the igniter. If you get it down in there, you'll end up with flashover and the spark goes the wrong way. It doesn't go across the electrodes, it ends up coming back up through the spark plug. Okay. So cleaning and inspection of the ignition ring. Okay, the output wells of the exciter, they have to be cleaned. What would you use to clean this stuff? So you got a little grease in there. Maybe you went to Popeyes and you had chicken for lunch and you got greasy fingers that put all this stuff together. What would you use? What kind of compound would you use to neutralize the grease and get it out?
Alcohol?
Alcohol, not so much. You can use alcohol, but I'll tell you what happens with alcohol as it flashes off and evaporates. What does it leave behind?
Everything you just tried to get away.
Everything you're trying to get rid of, yeah. And even if you get it pretty clean, it's going to cause condensation, and so you don't want moisture sitting there. You want to have it clean and dry when you move away from it. So you can use acetone, MEK, anything like that, electro contact cleaner, anything like that works just fine. Q-tips, you all know what Q-tips are? Cotton swabs. Cotton swabs, clean your ears with them. Anybody?
What?
Huh?
Yeah, so you use a cotton swab down in there with some of this, this compound, and it'll clean it right out. You wanna clean out the input wells on the igniter. You wanna wipe off the insulated ends on the harness. And once you get it clean, I wouldn't do the inspection first, but you have to have it clean enough so you can do the inspection. Once you get it clean, then start doing your inspection. You're looking for little hairline cracks or little black tracking marks on the ceramic. You're also looking for broken metal braid or the shielding on the outside of these wires. And there's something called an environmental seal. It's nothing more than a shaped silicone seal. This shaped silicone seal fits around the connectors, causes it to be weather tight. Not only weather tight, but it'll keep Skydroll out, hydraulic oil. It'll keep fuel out. And so you won't have anything leaking down into the spark plugs that cause them to flash over. Now, when you go to the CMM, the component maintenance manual, it will tell you how much braid can be compromised on the harness. Every engine manufacturer, every ignition manufacturer's got some different level of braid compromise. That is to say, if you've got broken braid on the outside of these wires, they're going to tell you exactly what percentage of that wire can be compromised. They're not all perfect. People step on things, people get things rub against things. Riding conditions. Any of you heard of a riding condition before? Riding conditions. Two things rubbing against one another. Don't want that to happen. In all cases, you want 1/10 of an inch between stuff, unless it's clamped together. If it's clamped together, they can be hard on one another, but ordinarily you want 1/10 of an inch between the two. That's a Boeing and an Airbus specification. And if it's not riding one on the other, it's not going to wear that shielding out. Now the exciters and the harnesses, there's nothing there that's repairable by mechanics except by certified repair stations. They take these things apart, put them back together, replace the parts in them, overhaul them, all of that, but there are no line replaceable units inside of these things. Okay? Keep your damn screwdrivers out of them. So the igniter plugs, they're replaced when they're worn or no longer functioning. Usually they run them, if there's a dual channel setup on the engine, they'll run them right till one quits, and then they'll replace it. They won't replace them in pairs. They'll run them until one quits, and then they'll let the other one quit in due time. Again, the wear and erosion limits are set by the manufacturers of not only the engines. You'll find these repair schemes or the limits, and also in the component maintenance manuals. So Unison, Champion, Autolite, all of those companies make these igniters, and they all have their own specific limits for wear and usefulness. Okay, glow plug maintenance. The only way you can check to see if the glow plug's working, you can't hear it switch and snap it, is to pull it out and connect it to the wire. Now, these aren't going to have a wire that's going to look like a harness wire for a high tension or low tension spark plug. This is just typically going to be a shielded wire that's 18 gauge, maybe 16 gauge wire that goes out and feeds voltage to the glow plug. And it comes from a glow plug controller. So the controller switches on, and it will run the glow plug for a period of time. Everyone's a little different. run it for 30, 40 seconds, and then we'll shut it off. We'll then go off for 30, 40 seconds, and then we'll come back on again, and that's called a duty cycle. Okay, so you remove the plug from the engine, and then you reinstall the ignition lead and switch on the ignition with the plug hanging outside the engine. So all you're going to be looking for is to see that the plug operates. Okay, so these things should get hot within about 8 to 10 seconds, and then you shut it off. You don't want to run these any longer than you have to. These things will get almost white hot, but you don't want to run the temperature that high. If it shows within about 10 seconds as yellow, yellow-orange, that's good enough. If you run them too long, the filaments get too hot, and the next thing you know, you burn your $650 glow plug out. Now this glow plug is going to be double hot, and so you're not going to want to handle it right away. You're not in any danger of any high voltage energy in this case. But what happens is the glow plug's so hot, you're going to have to put anti-seize on it, screw it back in, torque it back down, and reconnect the wire to it. It's a very good chance you're going to get burned. So let the thing cool down before you reinstall it in the engine. Okay, the last slide here. I'm going to show you a little video. Did I show you guys a video in the ignitions class the other night, CFM56? You probably remember. I'll go dig that out real quick, and I'll show you a little video before we close it down for a little break here. So the point here is that if you drop one of these spark plugs, and these are the igniters, not the glow plugs, if you drop one of these things, you're probably going to have a problem with it down the road. And if you have a problem with it down the road, that means the aircraft's probably not going to launch on time. You take one of these things and it hits the floor, you might as well just scrap it. Okay? They're expensive, but you might as well just scrap it because there's a very good chance the insulator has been cracked inside the spark plug. And it's the same with a spark plug for a reciprocating engine. It doesn't matter. What's going to happen is if you crack that insulator, you're not going to have the correct voltage delivered to the electrode to create the spark that you're looking for. Okay. So let me go get that video, and I'll run that off real quick. It's like 20 minutes or something, maybe less. But it's about CFM56 ignition system. Minutes. So these engines are in quite a number of Boeings, Airbuses, almost all the 737s anymore.
This program details the removal and installation of the CFM56 ignition system. Both Type 4 and Type 3 will be described. Before disassembly, ensure the system has been deactivated for at least 5 minutes. Remove the cooling shroud clamp and the cooling shroud. Once the cooling shroud has been removed, the ignition lead igniter plug interface will be exposed. Then loosen the ignition lead coupling nut and completely disengage it from the igniter plug. Next, gently remove the ignition lead from the plug. Be careful not to bend or kink the lead excessively during removal, as this could damage the ignition lead or plug. Then, with the lead completely disengaged from the igniter plug, unseat the igniter plug from the Type 4 adapter bushing. Do not remove the Type 4 adapter bushing. It should remain lock-wired and secured to the combustion case. The Type 4 adapter bushing is only removed if the igniter plug cannot be unseated from the bushing. The original adapter bushing, along with the equivalent shims between the bushing and the combustion case, should be used or igniter immersion depth will be affected. Ensure that the gasket between the igniter plug and adapter bushing came off with the plug. Proper installation of the igniter plug is very important. Since it is a wear-out item, it is the most often changed ignition system component. This system can be assembled many different ways. However, only one, described later in this program, is correct and ensures proper operation. Before beginning installation, have all of the needed hardware and consumables available. An igniter plug with captive gasket installed, a new chamfered silicone seal, and anti-seize grease. Be sure that hands, hardware, and tools are free from any dirt, etc. The conditions under which the ignition system operates makes it extremely sensitive to any type of contamination. First, remove the chamfered silicone seal from the ignition lead insulator, and be sure that the seal load spring remains in place on the lead. Then install the new chamfered silicone seal on the ignition lead insulator. Verify the proper orientation of the seal load spring and the seal. Note, be sure to install the chamfered silicone seal before applying any anti-seize grease to ensure cleanliness of the seal and igniter terminal well area. Next, coat the threads of the igniter plug that mate with the Type 4 adapter bushing with anti-seize grease. Then thread the igniter plug by hand into the bushing until snug. Torque the igniter plug to the torque value specified in the maintenance manual. Anti-seize grease is not used at the lead plug interface because of the threat of contamination to the Type 4 termination. Gently install the ignition lead into the igniter plug. Thread the ignition lead coupling nut onto the plug by hand until snug. Then, torque the lead coupling nut to the torque value specified in the maintenance manual. Finally, install the cooling shroud and clamp into place. For the removal of the Type 3 igniter plug, first cut the lock wire from the ignition lead coupling nut to the adjacent fuel nozzle. Unseat the ignition lead coupling nut from the combustion case and remove it completely. Gently remove the lead plug combination from the combustion case. Be careful that the plug does not fall out of the ignition lead. The igniter plug is held in place by the friction force between the pin and socket connection. In the event of a plug or lead malfunction, removal of the igniter plug may be difficult. Further troubleshooting may be necessary. Install the Type 3 igniter plug into the ignition lead and carefully coat the threads of the ignition lead liberally with anti-seize grease. Then install the ignition lead coupling nut into the combustion case and torque to the value specified in the maintenance manual. Then safety wire the coupling nut to the adjacent fuel nozzle. For Type 4, remove the cooling shroud clamp and shroud from the igniter plug ignition lead junction. Then remove the coupling nuts on the exciter end of the lead and on the igniter plug end of the lead. Open all of the brackets holding the lead in place. Loosen and remove the bolts holding the cooling air pickup junction plate. Then carefully pull the ignition lead through the fan frame. The ignition lead can then be removed from all of the other brackets and removed from the engine. When installing the Type 3 or Type 4 ignition leads, first make sure all brackets are in place and in good condition. Then insert the exciter end of the ignition lead through the fan frame strut and carefully feed the lead through the strut until the air adapter seats. Then tighten the clamps. Next, install the bolt and retaining plate that hold the air adapter in place on the number 3 fan frame strut. Run the lead in the proper clamps as specified in the maintenance manual. Next, gently slip the exciter end of the lead into the exciter connector and torque the coupling nut to the value specified in the maintenance manual. On the Type 4 ignition lead at the igniter plug end, replace the chamfered silicone seal. Verify proper orientation of the seal load spring and seal before installing the lead to the plug. Slide the cooling shroud clamp onto the ignition lead. Note, do not apply anti-seize grease to the plug lead interface threads. Next, gently slide the igniter plug end of the lead into the plug. Thread the ignition lead coupling nut onto the plug by hand until snug. Next, torque the lead coupling nut to the torque value specified in the maintenance manual. Then slide the clamp down over the lead and install the cooling shroud. Then tighten the clamp. On the Type 3 ignition lead, the plug is inserted into the lead. Then, anti-seize grease is applied to the ignition lead threads. The lead coupling nut should be torqued to the value specified in the maintenance manual. For either Type 3 or Type 4, slide the lead in the mounting brackets until optimum clearance from the engine hardware is obtained. Note, the left-hand lead has in the past had problems with chafing on the 2 o'clock VSV actuator bell crank. Verify that this area is not chafing. Once optimum clearance between the lead and other engine hardware is obtained, torque the ignition lead brackets to the values specified in the maintenance manual. Both low-energy and high-energy exciters are installed and removed from the engine in the same manner. Disconnect the power supply cable from the connector which is on the forward side of the exciter. Place a protective cap on both the cable and the connector. Then, disconnect the ignition lead from the connector on the aft side of the exciter. And cap the lead and the connector. Hold the stud in the resilient mount with an open-ended wrench on the stud flat so as to prevent the stud from turning. After removing the nuts and washers that secure the exciter to the bracket, remove the exciter. To install the exciter, make sure the circuit breaker is open. Lightly coat the mounting bracket stud with graphite grease
So those are shock mounts there.
and place the exciter on the studs.
If you don't hold those when you take the nut off, you can twist the
Secure the studs with bolts and
twist the
washers
stud right out of the
using an
shock.
open-ended flat wrench to keep the stud from turning. Connect the ignition lead to the connector on the aft side of the exciter and tighten. Make sure that the ground strap is connected. Connect the power supply to the connector on the forward side of the exciter and tighten. shows the circuit breaker. This concludes the removal and installation of the components of the ignition system. For more specific information, refer to the appropriate maintenance manual.
So how many of you think you could do that?
Hopefully everyone.
Hopefully every hand to go up here, because it just isn't that hard. It's a task, it's a pretty common task. You know, you don't do one every day, but it's a pretty common task that you might do. And you can see it's not just ain't that hard, but there's a little procedure to it, some things you have to remember. You go to the manual and you go up, one right after another. A lot of places use what they call job cards. And so a job card is replace the igniter, and it's got all those steps on there. You make a little stamp or you electronically put a mark on it. But know that something like this, you're gonna, at some point, you're gonna remember what the torques are. You're gonna remember kind of what the procedure is. But the one thing that I can't impress on you enough is keep that anti-seize away from the electrical. Okay? Keep that anti-seize away from the electrical side, or otherwise you're gonna have sparks going everywhere. That's not gonna be very helpful. Okay, so why don't you take, come back at a quarter till, and we'll go some more.
So what is that? Oh, no.